Question 8.3. If y equals x to the power of 6 minus 1, all to the power of 2, prove that dy dx, so the derivative of y, equals 12 x to the power of 5 root y, if x is bigger than 1. Alright, so very strange. Where does this y come from? If we're finding the derivative of y in terms of x, how do we now suddenly have x and y in our answer? Well, if we can't see it immediately, that's fine. Let's just work with what we've got. So we want to find a derivative of y, so let's do that first. Y equals x to the power of 6 minus 1 to the power of 2. Let's expand this out to make it easier to find the derivative of. That will be x 6 minus 1, x 6 minus 1. X to the power of 6 times x to the power of 6, we've got the same base, so we can plus the coefficients, plus the exponents, sorry. So that will be x to the power of 12 minus x to the power of 6 minus x to the power of 6 plus 1. Simplify, x to the power of 12 minus 2x to the power of 6 plus 1. All right, now let's find the derivative of y. Y prime will equal 12x to the 11 minus 12x to the 5, and the derivative of a constant is 0. All right, now we have the derivative of y, but that doesn't really look like the derivative they have. Oh, it does, but we don't have a y. But they do have a 12, and we have a 12. So this is a good example of probing the question. We don't really know instantly what we want to do, but let's try figure out and use tools that we do know in order to solve the problem. Well, I do notice that I have common factors. I've got 12, 12, and x. So let's pull those out and see what happens, just to see what happens. X, I'm going to pull out a 5. So then I'll have x to the power of 6 minus 1. Now this looks exactly like that. That's awesome. But this still doesn't look like that. But hang on. Now we go look back at what y used to be. And y used to be x to the power of 6 minus 1 to the power of 2. And that looks awfully similar to what we have. Except that their y is to the power of 2 and ours isn't. Well, if we wanted to get rid of that power of 2, what do you normally do? The inverse of a square is a root. And if y originally equaled x to the power of 6 minus 1 to the power of 2, if I wanted to get rid of this 2, I'd have taken the root on both sides, and now suddenly root y equals x to the power of 6 minus 1. Exactly what we have here. So doesn't it make sense to sub in root y here to get their root y? Completely. That's just a substitution, and that's fine to do. So to reiterate, I didn't know we had to do that. I found the derivative. I looked for common factors because we know to use common factors. It's one of the tools we've used. And I noticed that I also have a 12x to the power of 5, and their answer contains a 12x to the power of 5. So I first pulled out that common factor. I was now left with this. Not quite their answer, but very similar to what y used to be, and that couldn't be a coincidence. I found that if I took the root of x to the power of 6 minus 1 all to the power of 2, I'd then be left with root y equal x to the power of 6 minus 1. And x to the power of 6 minus 1 is exactly what I have here. So I subbed in root y, hence proving the answer that they came to. So a little bit of thinking here, but all we did was probe the question and look for similarities and patterns. And we were able to prove that their answer is indeed correct. And that is the question solved.